This is Open Line.
Good evening, everyone. Welcome to Open Line. I'm Carrie Sharp. I am glad you are with us tonight. It is your chance to get your questions answered by an expert in infectious diseases. Dr. David Aronoff is joining us once again. Of course, he is with Vanderbilt University Medical Center. Dr. Aronoff, thank you for spending the next hour with us.
Carrie, thank you for having me on. I'm really delighted.
We always learn so much while you're here, and I just think it's such a treat that folks can call in and ask their questions they've been wanting to ask an expert, not search on Facebook and Google. So this is your chance to ask an expert. 615-737-PLUS or 7587 is the number to call. I will get us started until Taylor gets those phone calls lined up in the back. And I want to talk about two things that are really circulating in the news right now. First being the vaccine, and also where we'll start is this new mutation or mutations of the coronavirus. What can you tell us about that? Because it sounds scary.
Yeah, so we're living in a really interesting time where we have the ability to do genetic sequencing on germs like the SARS-CoV-2 virus almost every day in real time for pretty cheap. That's pretty new for us. We didn't really have that technology until pretty recently, and that means that we can really see what's happening to the genetics of this virus as it spreads and continues to spread around and around the world. And what we're noticing is that the genetics change a little bit. Some of that is highly random, but if the genetics of the virus changes in such a way that it gives it an advantage, like maybe it's better able to hop from person to person or better able to replicate in a person, those kind of genetic changes may stick with the virus. And so what people are really looking for are changes to the virus that may make it more severe for us or make it more likely to hop from person to person. There have been a couple of these sort of mutant viruses, one that seems to have arisen out of the southeast of England and one that is in South Africa, where people are concerned that it may be more transmissible. It may hop from person to person a bit faster or better. We don't really know yet if that's the case. Scientists are really working on that to know. But where that is important is that the mutations in this virus seem to affect the little spiky bits on the outside of the shell of the virus in a part of the virus called the spike protein. In fact, if you look at these viruses under a high-powered microscope, these spiky bits look like a crown around the virus, and that's how coronavirus gets its name as a coronavirus, is because it looks like a crown. But those spiky bits turn out to be really important to help the virus attach to our own cells. It's almost like the Velcro for the virus. And if those mutate, they might be able to get around our immune response if we've been immunized to have antibodies directed at those spike proteins. And so the concern is that the virus could be changing in such a way that it would evade or go around even our immune system that's been stimulated with a vaccine. We have zero evidence that that's the case right now. And people think, I certainly think and hope, that the vaccine will actually protect against these sort of different strains that we're seeing. So we're keeping our eyes on it. Long-winded answer is, let's just keep watching. Let's get everybody vaccinated and get out from under this pandemic as soon as we can.
Is this typical behavior of a virus?
Absolutely. As a virus sticks in a population, and of course this one was new to people. It was never in humans before December of last year. But as it sticks into a population, it changes as it gets used to its environment, and the genetic code of it just sort of shifts through evolution. And we see that happen. That's what we're witnessing as we sequence these viruses. And so far, we have not seen evidence that the vaccines aren't going to work or that people aren't protected after they recover from infection, for example. So I think right now it's mostly just collecting stamps, kind of. We're just looking at this and asking questions.
Is Vanderbilt now looking for or testing for this new mutation of the virus?
Yeah, so we don't really have tests that say, oh, it's this strain from England, or it's that are available commercially. The commercial tests seem to be able to detect this variant of the virus just fine. So far, we haven't seen reports that either the strain that came out of Southeast England or the one that's been associated with South Africa have moved into the United States.
As we see you sitting in your office there at Vanderbilt, I presume you could be at home, but it's easy to disassociate you with making the rounds there in the hospital and treating COVID patients. Could you tell me about what you are doing day in, day out when it comes to COVID patients?
Yeah, sure thing. I mean, unfortunately, we have a lot of patients in the hospital. In fact, across the state of Tennessee, there are nearly 3,000 patients right now in hospitals. In Davidson County, there are nearly 500 patients with COVID-19. Our hospital has a lot of patients, and we take care of them in part by bringing different experts together and discussing every single patient every day. So almost 7 days a week since March, I've been involved in the daily care of our COVID patients. We now have the census. We have enough patients in our hospital that really we join a lot through things like Zoom, and we talk with the bedside providers about each patient, and we look at their records, we look at their x-rays, we talk about how they're doing, and make sure that they're on the best treatments, that we're looking for any complications of the COVID-19 infection in these folks. And it's really motivating to come in every day and work as hard as I can against this pandemic, because I can see every single day people struggling to live and to make it into 21 with COVID-19.
Can you generalize what you're seeing in patients? I read not too long ago, it may have been a month ago now, but that the patients that people were seeing were typically younger now and also more severe. Are you seeing that, or are you seeing something different?
Well, because we're a referral large tertiary care medical center, we tend to get a lot of pretty sick patients. We have a lot of people who are severely ill with COVID-19. And I think the experience in Tennessee is the same as we're seeing across the country, that a lot of people get infected with COVID-19, but the people who tend to get the most ill are people over the age of 65 or people with multiple medical problems like high blood pressure or diabetes, obesity, or having a compromised immune system, or people who are really at the extremes of age, like over 80, for example. Our hospital population is pretty true to that, but I can tell you that we absolutely have young people in the hospital right now with COVID-19. It's just that it's less likely that a young person will end up in the hospital. But if you get enough of them infected, you start to see that. And it's, looking at a 25-year-old who has no medical history in the intensive care unit from COVID may be a low frequency event, but it's something that I wish was a never event.
Sure. We were warned about a post-Thanksgiving surge, and here we are. Is it what you expected it would be?
Well, I really, throughout this pandemic, have had trouble knowing exactly what was going to happen because there are so many factors at play. But it was definitely a concern that as people gathered, we'd see more infections. The mathematics of how this occurs is not very complicated. The virus moves from person to person through our breath. And unfortunately, a lot of the transmission events occur silently from someone who's infected. They look well, they feel well, they have no idea they're contagious. The virus goes into somebody else, and so on and so on. As people gather, more of those transmission events occur. That translates into eventually more people going to get tested, usually because they're symptomatic. And then, out of every 100 people who gets tested and diagnosed with COVID in our state, about 3 end up in the hospital, and about 1 ends up dying of the infection. So as we anticipated, gatherings would lead to more cases, which would lead to more hospitalizations and lead to more deaths. I was really hoping that we wouldn't be at this point where our hospitals are getting full, where staffing is really a very important rate limiting step here. We have beds, but we don't always have enough people to care for the patients across the state. That's something that Lisa Piercy talked about recently in a press conference this weekend. So I'm really bracing for what could happen coming into this holiday season.
Let's get to the phone lines. We have Ron calling in, our first caller of the night. Ron, thank you for being with us. Go ahead and ask your question. Ron, you're on the air. If you're still with us, you can ask your question.
Yeah, my question is, do they not know that virus is going to mutate because of, in Denmark a while back, 17 million mink were killed when they were testing this virus vaccines on the mink over there, and did they not realize that vaccine was going to cause that virus to mutate to that point? Will it mutate to that same point as they give these vaccines here in the United States?
Okay, good question. And if you're saying mink, there is some evidence that this extends from a mink farm, right, doctor?
Yeah, Ron, thank you for that question. It's a really good one. And so a couple things to say. First of all, this coronavirus has shown that it can hop from humans to people and from animals to humans and humans to other animals. And so we've seen it move from bat populations into humans. And now we've also seen it affect livestock and farmed animals like mink in Europe seem to be susceptible to this virus. To my understanding, the minks weren't infected because of vaccine trials. They were infected by the actual virus itself. The virus itself got into the mink populations on these big farms, and unfortunately, because they were infected and sick, they had to be basically culled. And so millions of mink had to be put to death because the virus got into those populations. But that was not related to vaccine testing or use of vaccines. The vaccines that we're using here, the whole purpose is to put a stick in the spokes of this pandemic. The purpose is to stop the spread of this SARS-CoV-2 virus and save lives and get us out from underneath this pandemic. So those are two sort of separate issues, but I really appreciate you bringing that up.
Can we talk a little bit about the vaccine now? You got the vaccine recently.
I did. I got the mRNA vaccine that's made by Pfizer. I got it this past Saturday. Both the Pfizer vaccine and the Moderna vaccine are very, very similar in the way that they work. They're very effective vaccines. The clinical trials showed that they prevented 95% of the symptomatic COVID infections in the trials, which I think is even better than any of us really anticipated. So we're really excited to have these. I think now it's a matter of being able to manufacture and distribute enough vaccines to immunize over 300 million people in the United States.
I picked up on one thing you said there about it showing effectiveness in the symptomatic infections, but so much of this and so much of the spread is because of asymptomatic folks. So then what?
Well, the first thing that we really need this vaccine to help us to prevent are people suffering from this infection. We need the vaccines to prevent people from getting sick with symptoms that may cause life-altering problems, from people getting hospitalized or developing complications like blood clots or strokes, or dying from the infection. First and foremost, that's one of the things we need the vaccines to do. What we're going to learn later, and we really don't know the answer now, is the extent to which the vaccines absolutely prevent asymptomatic infection. My guess is that they work a lot like flu vaccines, which is that they will likely shorten any infection. So if I get infected after being vaccinated for COVID, I may still be able to get infected, but that infection may be very short-lived because I have immune response against the virus. I probably won't have symptoms, which would be great. And if I'm contagious, it hopefully will be for a short period of time. So we don't know yet if the vaccine absolutely prevents infection and contagiousness, but it probably does reduce those things quite a bit. But again, keeping people from suffering is really, really important. And if this virus only caused asymptomatic infection, I don't think we'd want a vaccine in the first place.
What else don't we know about the vaccine?
Well, we haven't yet completed trials in young children with the vaccine, for example. So remember early in the pandemic, we thought that maybe children didn't even get infected with the SARS-CoV-2 virus because most of the people, as is the case today, who get sick with this are adults. We've subsequently learned, of course, that children can get infected. They can be contagious. They can transmit the virus to other people, but they are less likely to get seriously ill with it. But of course, when we first designed vaccine clinical trials, we were really targeting the populations of people who were getting sick, which were adults. So these big phase 3 studies really did not include people younger than the age of 16. So now there are trials going for young children. It is likely to be very effective in children, and it's likely to be safe in children. But until we know that, we can't really say that. We really have to do the studies. And so that's a group where we need more information.
All right, we're going to take a quick break, let you catch your breath. And I want to let you know the phone lines are open. If you want to give us a call, we will get those lined up. You can ask your burning COVID questions to Dr. Aronoff yourself. 615-737-PLUS. Stay with us.